Okay, so this is section 2-4, geometry, deductive reasoning. So in the last time we talked about reasoning, we talked about inductive reasoning, making a conjecture based off of patterns, more like a educated guess. This time we're now talking about deductive reasoning. And when we talk about deductive reasoning, deductive reasoning sometimes called logical reasoning. You're going to make a logical conclusion based on the facts or based on statements. So you're not just looking at patterns anymore. You're going to be given a set of facts and a set of statements, and you're supposed to make a logical conclusion rather based off of that. Law of attachment is one of the first. There's two of deductive reasoning, law of detachment, and it says this. If the hypothesis is true, then the conclusion is true. That is the law of detachment. If the hypothesis is true, then the conclusion is true. Based on symbols, we can say if P is true, actually not at the given a true conditional. So if the conditional is true, then the conclusion is true, given the fact that the conditional is true. Given the fact that the conditional is true. Okay, so with the symbols, if P then Q is true, then P is true. If P is true, then Q is true. Alright. So when we use the law of attachment, let's go through a couple examples. Here it says that it's given that if a student gets an A in an exam, then the student will pass the course. So that's a true statement. We're told that that is a true statement. If you get an A on the exam, then the student will pass the course. Here is our statement. Felicia got an A on her history exam. Well, if Felicia got an A on our history exam, final exam, then we can conclude that Felicia had an A will pass the course. So if you get an A, you will pass the course. Felicia got an A. Then I can say that Felicia will pass the course because that is the conclusion. The student, which is Felicia, will pass the course. Here, if a ray divides an angle into two congruent angles, then the ray is an angle bisector. Then they give me the statement here that ray AS divides ARB such that they are congruent angles. A ray divides it into congruent angles. Then we can say that the ray is an angle bisector. So we can say that ray RS is an angle bisector. Okay. Here's our information. If there is lightning, then it is not safe to be out in the open. Marla sees lightning in the soccer field. What can we conclude? We can conclude that it is not safe to be open in the soccer field. Part B says if a figure is a square, then it has sides, then its sides have equal length. It says figure ABCD has sides of equal length. Okay, we can't make a conclusion about that. And the reason we can't make a conclusion about that is because the law of detachment says that the hypothesis has to be true, not the conclusion. In the case of this, figure ABC has equal sides. That's the conclusion part. Since it's validating the conclusion, I have no idea what the hypothesis is. I can't use this reasoning. I have to first prove that the hypothesis is true. If the statement says the hypothesis is true, then I can make a conclusion. I can't start with the conclusion first. I always have to start with the hypothesis first. The next one is the law of syllogism. And the law of syllogism says this. We have two statements. If P then Q is true, and Q to R is true, so we have two statements, then P then R is true. This is almost like the transitive property of equality. If A equals B and B equals C, then A equals C. This is the same thing. If the hypothesis, we're going to have two statements. First one is the hypothesis of the first statement gives me the conclusion of the first statement. Then I have the conclusion of the first statement is now the hypothesis of the second statement. Then I can conclude in my third conclusion, or I can make a third conditional statement. Then I can say that the hypothesis of the first statement can give me the conclusion of the second statement, if P then R. The Q's essentially cancel itself out. The hypothesis of the first is equal to the conclusion of the second, if P then Q. So hypothesis of the first and the conclusion of the second of the first is true. And then the conclusion of the second is equal to the hypothesis of the first. So the hypothesis of the second is equal to the conclusion of the first to the second conclusion is true. So since these guys are the same, they can go away. Then I can conclude that the hypothesis of the first will give me the conclusion of the second, and that would also be true. That's the law syllogism. So let's look at an example down here. It says that if a whole number ends in 0, then it's divisible by 10. So if a whole number ends in 0, then it's divisible by 10. Then I can say if a whole number is divisible by 10, then the whole number ends, then it's divisible by 5. Our statement is going to be this would be our first statement, this would be our second statement. So then what can we conclude? We can make a third statement, and we can say, okay, the conclusion of the first statement is the same thing as the hypothesis of the second statement. Those guys can go bye-bye. And I can be left with the conclusion of the second and the hypothesis of the first. So I can rewrite this and say if a whole number ends in 0, then it's divisible by 5. Then it's divisible by 5. Again, since the conclusion of one is the same as the hypothesis of the other, those guys can cancel each other out, and I can be left with the hypothesis of the first and the conclusion of the second. This doesn't work if the hypothesis of one is the same as the hypothesis of the second, or the conclusion of one is the same as the conclusion of the second. It won't be able to cancel out. It only works when it's the hypothesis of the first and the conclusion of the second, or vice versa. You can mix detachment and conclusion together. So in the case of the example that they give, they say if you live in Accra, then you live in Ghana. If you live in Ghana, then you live in Africa. And then it says Aisa lives in Accra. So two things are going on here. We have the law of syllogism. If you live in Accra, you live in Ghana. If you live in Ghana, you live in Africa. So if we write the third statement here, then the third statement would be, if you live in Accra, then you live in Africa. Then you live in Africa. So that's the law of syllogism. Now, the law of detachment comes into play when they give me a true hypothesis statement, and it says that Aisha lives in Accra. So if Aisha lives in Accra, then I can conclude based off of the statement that Aisha lives in Africa. I can conclude that Aisha lives in Africa. Here it says the river is more than 400 miles long, then it's longer than Amazon. If a river is longer than Amazon, then it's the longest river in the world. And it says that the Nile is 4132 miles long. So what can I conclude? I can conclude then that the Nile is the longest river in the world. All right, that is this section. I hope you have a great rest of your day.